Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends. In this video, we are going to study about the pressure measurement device McLeod gauge. So here we will study its construction, its principle of working, along with its application, advantages and its limitations. So let us start with our topic. So McLeod gauge is an instrument which is used for the measurement of low pressure, generally up to 10 raised to the power minus 6 torr. Means such low vacuum pressures can be measured with the McLeod gauge. So it is used to measure very low pressures down to 10 raised to the power minus 6 torr. Now McLeod gauge, it was invented by the scientist Herbert McLeod. So it is named after the scientist who invented. So it was invented in 1874 by Herbert McLeod. That is why it is known as the McLeod gauge. Now if we see the design of the McLeod gauge, in its design it is similar to the mercury manometer, which is the basic and the most common instrument which is used for the measurement of pressure. So in its construction, or we can say in its design, it is similar to the mercury manometer. Just like mercury manometer is having mercury in it, and the pressure measurements are done by seeing the changes in the mercury level. So here also in the McLeod gauge, it is filled with the mercury. So when we are handling this instrument McLeod gauge, some precautions should be taken care so that the mercury, it cannot damage, it cannot come out of the instrument and cannot damage the surrounding devices. Okay. Now let's see that how this McLeod gauge it operates. So we can let's see the principle of working of the McLeod gauges. So McLeod gauges, they operate by taking in a sample of gas from a vacuum chamber. So the pressure which we want to measure, first we are going to take a sample of gas. Now we are going to compress that sample of gas, and how the compression is being done by tilting and infilling it with the mercury. So with the help of mercury we are compressing a small sample of the gas. So we know the initial volume of the gas which we have taken, and when we are compressing it, we know that what will be the final volume of the gas after the compression. Now when we have compressed that volume of the gas, earlier volume we know, final volume of the gas we also know after the compression. Now we are going to measure the pressure of that small volume of the gas or that compressed volume of the gas. So what we know, the initial volume of the gas, the final volume of the gas, and also the final pressure of the gas. So the initial pressure of the gas can be measured by using the Boyle's law. So pressure of this smaller volume is measured by using the mercury manometer, and we know knowing the compression ratio of the original vacuum can be determined by using the Boyle's law. So that is how the McLeod gauge works. That first it is going to take a sample of gas from a vacuum chamber. So sample of gas, we know that how much amount of gas we have taken. So we know the initial volume of the gas. Now we are going to compress this gas, means we are applying the pressure on the gas. Due to the compression, its volume will also decrease. Okay, so we know the final volume of the gas also. Now of this final volume of the gas, we are going to measure the pressure, okay, by using the mercury manometer. So we know the final pressure also, okay. So by knowing the compression ratio, that it's initial and the final volumes, and also the final pressure, we can find out the initial pressure or the pressure of the original vacuum by using the Boyle's law. Okay, so we can say that the working of the McLeod gauge, it depends upon the Boyle's law and it is based on it. So let's see that what is the Boyle's law and how we can measure the pressure from it. So we can say that the basic principle of the McLeod vacuum gauges is that a known volume of gas is compressed to a smaller volume whose final value provides an indication of the applied pressure. Now we know that the gases, they must obey the Boyle's law, which is given by the equation. And the Boyle's law says that P1 V1 is equals to P2 V2. Okay, that means the initial pressure multiplied with the initial volume is equal to the final pressure multiplied with the final volume of the gas. So initial volume of the gas, we know, we have taken a known volume of the gas. Final volume we also know because we have compressed this to a smaller volume. So final volume of the gas is also known to us. Final pressure of the gas is also known to us because we have measured it with the help of the mercury manometer. So we can find out the initial pressure of the gas by using this Boyle's law equation, that is P1 V1 is equals to P2 V2. Here P1 is the initial pressure, or we can say that it is the applied pressure which we want to measure. V1 is the initial volume, P2 is final pressure, and V2 is final volume. So we can say that the initial condition is equal to the final condition. Initial condition means before compressing the air, what is the volume and pressure of the gas, and after compression, what is the final volume and final pressure of the gas. So after compression and before compression, these conditions are equal. Initial condition is equal to the final conditions of the pressure and volume of the gas. So that is the Boyle's law, and using this Boyle's law we are going to measure the applied pressure or the pressure of the vacuum. Now let's see the diagram of the McLeod gauge, and with the help of that diagram we are going to study the working of the McLeod gauges. So this is the diagram of the McLeod gauge. Okay, here you can see in this diagram we are showing the different parts of the McLeod gauge. We are having a measuring capillary, bulb, cutoff point, reference column, reference capillary, piston, and the mercury reservoir. So let's see the construction of the McLeod gauge. A reference column is there with the reference capillary. This reference capillary tube, it has a point which is called the reference point. Here you can see in the diagram that we are showing on the reference capillary, the different markings are there from 0 to 5. So 0, this is the point which is called the 0 reference point. And the pressure which we want to measure, that is applied in this reference column or in this reference capillary. Now this reference column which is having the reference capillary, this reference column is connected to a bulb and the measuring capillary. You can see in the diagram that this reference column, it is connected with the measuring capillary and the point where the bulb, where the reference column is connecting with the bulb and the measuring capillary, that point of connection is called the cutoff point. You can see in the diagram also that where the reference column is joining with this measuring capillary and the bulb, that point is called the cutoff point. It is called cutoff point because if the mercury level is raised above this cutoff point, the entry of the applied pressure to the bulb and the measuring capillary will be cut off. Okay, because when the mercury level is raised above this cutoff point, the entry of the flow of the pressure from this reference column to the measuring capillary and bulb, that will be cut off. So that is why this place of connection is called the cutoff point. So if the mercury level is going to be raised above this cutoff point, this point is going to cut off the entry of the applied pressure to the measuring bulb, capillary and the bulb. That is why it is called the cutoff point. Okay. Now below this reference column and this measuring capillary and the bulb, we are having a mercury reservoir, and this mercury reservoir is operated with the help of the piston. So this was all about the construction, and we have seen that the main parts of the McLeod gauge, that is the reference column, reference capillary, measuring capillary, bulb and the mercury reservoir. We have seen the zero reference point and the cutoff point also in the diagram. Now let us see the working of the McLeod gauge, that how this gauge measures the pressure. McLeod gauge is using the Boyle's law for the measurement of the pressure. So first of all, we have to apply the pressure on a known volume of gas. So you can see in the diagram that the pressure which we want to measure, that is applied to the reference column. So first step is to the pressure which we want to measure is called the initial pressure, that is P1, and that is applied to the top of the reference column. Now for the Boyle's law, what we are doing, the pressure which we have applied, now we have to get a volume of gas. We have to find out the known volume of a gas. Okay, so what how we can do that? We will operate this piston. With the help of this piston, we are going to press it, and by pressing this piston, we are going to increase the level of the mercury in this measuring capillary. Okay, and this level we are going to raise it up to a level which is shown by this green color. Okay, so up till this cutoff point, we are going to raise the level of the mercury. Now when this mercury level is raised, you can see that it is below this cutoff point. Okay, so at this condition, the applied pressure, it is being given to the measuring capillary and the bulb. Okay, so this applied pressure is going to fill the measuring capillary and the bulb. No, so in the second step, what we have done, we were increasing the level of the mercury by operating the piston, so that we can fill a amount of volume of the gas. Okay, an amount of gas can be filled in the bulb and the measuring capillary. So we are pressing the piston so that mercury level is increasing. Okay, so third step is that when this happens, the applied pressure, it fills the bulb and the capillary. So when we are increasing this pressure on the piston, or we are pressing the piston and we are increasing the mercury level, this applied pressure is going to fill the mercury, this measuring capillary and the bulb, because from here the applied pressure is coming. Okay, pressure is coming out here, and from here also we are pressing the piston, so mercury level is increasing. Now when this mercury level, it reaches the cutoff point, the measuring capillary and this bulb, it is filled by some amount of gas in it. Okay, so the level is increasing. When it reaches to the cutoff point, we will have a known volume of gas in the bulb and the measuring capillary. So we are going to note that volume of the gas. Okay, so first we have got the initial pressure also, that is the pressure which we want to measure. We have got the known volume of the gas also. Okay, that is our initial volume. Now we have to find out the final pressure and the final volume of the gas. For that, what we will do, So when when we were pressing the piston and when we were increasing the mercury level up to the cutoff point, at that point we have got the known volume of the gas. At that time we have noted the volume of the gas which is present in the bulb and the measuring capillary. Now that volume was the initial volume. Now again we start increasing the level of the mercury above this cutoff point to a point when it reaches the reference point. Okay, up to a level when it reaches the zero reference point. So at that time, when we are increasing the level of the mercury, the volume of the gas which is present in the bulb and the measuring capillary, it starts compressing. Okay, so initial volume we have known. Now we are compressing that gas. So after that compression, we are going to note the volume of the gas which is present, and that volume will be called the that volume will be called the final volume of the gas, and that is shown by this blue color. Okay, so first the mercury level is being increased up till this cutoff point. At that point we are noting the volume of the gas. After that again the mercury level is increased up to a point which is called the zero reference point. At that level the volume of the gas which is present in this bulb and this measuring capillary, here it is given by this free space. Okay, white space you can see. So this much amount of volume of the gas is being left. Okay, we have increased the level of the mercury up till this point, zero reference point. Okay, so at that point we are going to again note the volume of the gas, and that will be the final volume of the gas. Now in the second time we have increased the level of the mercury up to the zero reference point. So when level reaches to zero reference point, we are having a volume of the gas which is present in this measuring capillary. So we are going to measure the volume and the pressure of this gas which is present in the measuring capillary. So the difference in the height of this measuring capillary and the reference capillary, which is denoted by H, that is a measure of the volume and the pressure of the trapped gas. Okay, so this volume of the gas which is present here, we are going to find out its volume and its pressure, and that will be the final volume and final pressure. So volume will be V2 and pressure will be P2. Now V1 we already know, P1 we have to find out, V2 and P2 we have already calculated. So now we are going to use the Boyle's law. Now according to Boyle's law, P1 V1 is equals to P2 V2. Okay, so P1 is unknown to us, V1, P2 and V2 we already know. Okay, so let us find out that what is the volume and what is the pressure values, and then we are going to substitute their values here and we will find out the unknown pressure. Now let us suppose that the volume of the bulb from the cutoff point up to the beginning of the measuring capillary is V. So this is the cutoff point, and this is the point from where the measuring capillary is starting. So the volume of the bulb from this cutoff point to this measuring capillary is capital V. Okay. Now area of cross section of the measuring capillary is A. This is the measuring capillary. Its area of cross section is small a, and its total height is HC. Okay, height of the measuring capillary tube is HC. So when at the first time when we have increased the level of the mercury up to the cutoff point, so the volume of the gas which is trapped in the bulb and the measuring capillary, that will be equal to the area of cross section of the capillary tube into its height, means the total volume of the measuring capillary plus the total volume of the bulb. So initial volume of gas trapped in bulb plus measuring capillary, that will be equal to the volume of the bulb, that is V, plus the volume of the measuring capillary. So volume will be equal to area into the height. So A into HC. You can see it from the diagram. We have seen here that the volume of the bulb from the cutoff point to the beginning of the measuring capillary, that is V. So this much part up to this cutoff point is V. So this volume will be V plus the volume of the measuring capillary, which is height multiplied into the area of cross section. So area of cross section is A, height is HC, and volume of the bulb is V. So we have added this, and this is the initial volume of the gas which is trapped. P1 was the applied pressure. Of the gas, which is unknown to us, and this is the V1, that is initial volume. Now comes the final volume. So when the mercury reaches the zero reference point in the reference capillary, that will be equal to V2 plus AH. Okay, V2 means the volume of the gas which is trapped plus the AH. This much volume is present here. H is the height, A is the area of cross section. So we have find out this AH. Okay, plus means this V2 is equals to AH. Okay, now the pressure, now the final pressure will be equal to the initial pressure plus the height here. Okay, so means that we are having the P1, that is the initial pressure of the gas here, plus the pressure of the gas which is trapped here. So it will be P1 plus H. Now putting the values of all these variables in the Boyle's law. So initial and the final conditions are known to us. So we are going to put these conditions in the Boyle's law. And according to Boyle's law, P1 V1 is equals to P2 V2. Putting the value of the P2 and the V2 pressures, P2 and V2, the final conditions. We know that the final volume is AH and the final pressure is P1 plus H. So we have put here the value of P2 and the V2. So P1 will be P1 V1 equals to P1 AH plus AH square. Okay. Now bringing this P1 term to the left hand side. Taking P1 common, we are left with V1 minus AH equals to AH square. So P1 will be equal to AH square divided by V1 minus AH. Now A is the cross section of the measuring capillary and H is the volume or the height of the capillary after the compression. Okay, so this H is also very small, A is also very small, so this whole term AH is very small. That is the volume of the gas. Okay, so P1 can be written as AH square divided by V1. So by using this formula we can find out the applied pressure, because P1 is the pressure which we have applied or the pressure which we want to measure. V1 is the volume of the gas, the initial volume of the gas which we have taken. A is the area of cross section and H is the height of the measuring capillary in which the gas is being trapped at the final conditions. Okay, so using that we can find out the applied pressure. So in this way we can see that the McLeod gauge can be used for the measurement of the pressures. So this was all about the working of the McLeod gauge. Now comes the advantages. If we talk about its advantages of McLeod gauge, its first advantage is that it is independent of the composition of the gas which is used, that what are the different elements of which the gas is made up of. So it is independent of the composition of gas. Because only the volume and the pressure of gas is being considered here. Okay. The McLeod gauge is also used as a calibration standard or as a reference standard which is used to calibrate the other pressure measuring gauges. Also, there is a linear relationship between the applied pressure and the height of the capillary, measuring capillary. Also, there is no need of doing any corrections to read the McLeod gauge. So these are some of the advantages of the McLeod gauge, that it is independent of gas composition, it serves as a reference standard to calibrate other gauges, a linear relationship exists between the applied pressure and the H, and there is no need to apply corrections to the readings of the McLeod gauge. Next comes the limitations, or we can say the disadvantages of the McLeod gauge. The first limitation is that the gas whose pressure which we want to measure, that gas should obey the Boyle's law, because the working of the McLeod gauge is based on the Boyle's law, that final conditions are equal to the initial conditions P1 V1 equals to P2 V2. So if the gas does not follow the Boyle's law, the McLeod gauge cannot be used in that case. So it is the first limitation that the gas whose pressure we want to measure, it should obey the Boyle's law. Now in the McLeod gauge we are considering the pressure and the volume of the gases. So if by any means the pressure and volume are changing, that is going to affect the readings of the McLeod gauge. So if vapors are present in the gas, so that vapor is going to affect the readings. So for that, moisture traps should be used so that the vapors can be avoided to enter into the McLeod gauge. The other two limitations are that the McLeod gauge cannot this measures only on a sampling basis, and it cannot give a continuous output of the readings. So these are the limitations of the McLeod gauge. If we talk about its application, we have seen here that the McLeod gauge, it is used for the measurement of the low pressures, that is the vacuum pressures. So in this video we studied about the pressure measurement device McLeod gauge, which is used for the measurement of very low pressures up to 10 raised to the power minus 6 torr. We studied its construction, its working, its principle and its applications, along with advantages and the limitations. So I hope that this topic is now clear to you. Thank you.